In this video, I'm going to show you how to use custom formatters in C++ to generate good-looking output like you see in this window. So stay tuned. Let's start by opening a brand new Visual Studio and creating a new console application. So we'll create a new project and we'll select Console App for C++ and hit Next. And we'll name this Custom Formatter Example. Create. Let's start by editing the project properties so that we're using C++20 as our standard. So right-click the project, select Properties, and under C++, select Language, and where it says C++ Language Standard, we're going to drop down and select C++20 because we need C++20 to use the formatting capabilities. And so we need to include the format header if we're going to write custom formatters. So we're just going to include format. And also for this particular example, I'm going to use the new chrono date and time functions. So we'll include chrono also. Let's create a struct called transaction that we'll use for our example today. So we're going to pretend this is like a transaction done, say, in a personal budget application. And we're going to give it 4 fields. The first is going to be a transaction type. So I'm actually going to create an enum class to handle the 2 types of transactions I can think of right now, which would be deposits and withdrawals. So let's create an enum class called transaction type. And let's give it 2 elements. One is deposit and one is withdrawal. And so the first member of our transaction struct will be a transaction type. We'll call it m_type. Then let's use the year, month, day class from Chrono library to create a date. And we'll call it m_date. Let's create a string that we'll call comment. m_comment. Imagine in an old checkbook where you would have a transaction, you would kind of write down what this transaction represented. And finally, we'll have a double to represent the amount of the transaction, which, if you were using a real budgeting software, the amount may not be represented in a double because of floating point rounding errors and stuff, but just for this example, that's what we're going to use today. And to make life a little bit easier when we're creating these transactions, we're going to use the chrono namespace so that we can use the nice year operator and day operators that they have, which are like little suffixes at the end of the values. I'll show you what I mean in a second, but we're going to use that namespace. And what I would love to do is be able to create a transaction and print it out nicely. So the first transaction I'm going to create, we'll call it transaction 1. And I'll use the struct initializers that you can do in C++20, where you do the dot, then the member you want to set and its value. And the first one will be a withdrawal, comma. And we'll set the date to 2024Y. The Y there stands for year, /October /7D, meaning the 7th day of October, because that's the day I'm making this video. And then we'll do a comment that says groceries. And let's say the amount was, $62.81. Good. I would love nothing more than to be able to write cout, std format, transaction 1, semicolon, maybe do a new line at the end so that we can do more. But if we run this, we're going to have problems. because std format has no idea what a transaction is. And if we look at the output, yes, it's yelling at me that parse is not a member of std formatter. And there's lots of other errors and stuff going on. And the fact is, std format is nice, but it has no idea what a transaction is. So if we want to print our transaction nicely, we're going to have to figure out how to do that. So I'm looking at the reference of std format at cppreference.com. There's a couple things I want to point out to you about std format. So if we scroll down a little bit to the parameters, it tells you here that it can handle certain types. So it can handle basic types, chrono types, range types, pair, tuple, etc., etc., etc. But right down here at the very bottom, it says that for other formatable types, the format specification is determined by user-defined formatter specializations. In other words, we can define a specialization, a formatter, that will allow us to tell std format how to print our custom types. In other words, we should be able to pull up Visual Studio and create a custom formatter. Struct std formatter for our type, which is transaction. Now we're going to have to fill in some information here into this formatter before we can use it. So what is a formatter? If we scroll up here, there's a certain class called std formatter, and it has a few requirements. One is that it must satisfy basic formatter, whatever that is. So we're going to have to figure that out. And the other is that the parse function of an std formatter must be const_expr, since whatever this document is. So right now we know that we have to satisfy basic formatter, and we have to have a parse function that's const_expr. So let's click on basic formatter to get a little more information about what we're going to need for this specialization. So it says basic formatter is a type that abstracts formatting operations. Specializations of std formatter are required to meet the requirements of basic formatter. So what are the requirements? It has some construction and assignment requirements. Then it says, given the following types and values, the expressions shown in the table below are valid and have the indicated semantics. So I'm going to jump down to the table and look at what we have to have here. First, we need to have a parse function, and then we need to have a format function. Now, I remember reading on the previous page that the parse function must also be const_expr. So let's create a parse function and a format function according to this table. We'll start with parse, and we realize that it has to have a return type of parse_ctx iterator. And we'll have to figure out what parse_ctx is also. But I'm going to copy that, and we'll paste that in there, and we'll create a function called parse, remembering that it has to be const_expr. And what are the arguments for the parse function? It is a thing called parse_ctx. So I'm going to copy that in there. And now we'll look at what parse_ctx type and the parse_ctx argument represents, so we can get rid of the errors here. If we scroll up, the parse_ctx stands for a std basic format parse context. And if I click on that and we look here, we'll see that there are some type defs that we can use here. One for the regular char type, which is std format parse context. I don't really know what this is yet, but I do know that that's what the parse_ctx represents. So I'm just going to create an alias, say using parse_ctx equals that std format parse context. Again, whatever that is. And then the first argument, little parse_ctx, is an L value of type parse_ctx. And it satisfies some conditions. It has a begin iterator, it has an end iterator, and it says that in the range parse_ctx.begin, parse_ctx.end, it's going to parse some format spec for our arg type. It should throw an error if the whole range is not parsed. what it's going to do is return an end iterator of the parse range. Just to get us going here, I'm not going to worry about parsing any format specs. I'm just going to return the end iterator from that parse range. But we know that parse CTX is a parse CTX type. So I'm going to paste that in. And since we are dealing with potentially moving and updating end and begin iterators, I'm going to pass a reference to parse CTX. I think that's what I want to do, and so that's what I'm going to do. But just to make life easy for now, instead of parsing anything out, I'm just going to return that end iterator. And hopefully it won't yell at me when I try to build this. Now we're also going to need a format function. And the format function formats arg according to the specifier stored in F, writes the output to some out iterator, and returns an end iterator of the output range. So again, similar to what we did with parse, I'm just going to build this up. So this is the return type of the format function. I'm just going to paste that there. We'll write format. And the arguments to this function are going to be arg and fmtctx. You still have to figure out what those mean. Okay, so let's figure out what capital fmtctx stands for. And if I scroll up here, we can see that it's in the std basic format context. It takes some template parameters. But if I come into the page for this type and look at it, there is an alias called format context, which is the char type, unspecified. I don't know what that really means right now, but right now I'm just going to look at format context. So I'm going to say using fmtctx equals std format context. And then I'm going to look at arg, and it looks like arg is an L value of type capital arg. And capital ARG is the formatting argument type. In other words, I think that's our transaction. So I think we can pass a const reference to a transaction here. And we'll call it arg just to be in line with, what's written in this table. So transaction is the actual arg we're going to be passing in. Now fmt little ctx is going to be an L value of type fmtctx, so it's going to be a format context. And it says that when we're using the format function, our object has to be possibly const qualified. In other words, we have to be able to call the format function for a const type, which means the function itself should be const. So I'm going to do fmtctx, pass in a reference, but the function itself should be const. And we're going to return an end iterator. So I think what we're going to return is that fmtctx.out. So we'll just return that. And we're going to pray for a miracle. Right now we're not telling the format function to do anything, but I sure would love to be able to run this and see that it actually just builds with no build errors. That would be super nice. Okay, so it did build, it did run, it did not print anything out at this time, but that's because we didn't tell the format function to do anything. So next, let's see if we can figure out how to get some information out of the format function. The fmtctx out iterator, I'm hovering over it, and it says there that it's a back insert iterator. So it should work with things like std copy. In fact, pretty sure there's a format to function we can use to write formatted data to an iterator. Yeah, std format to. Formats args according to a format string and writes the results to an output iterator. So we should be able to do something like std format to Okay, it wants the output iterator first, so we'll do fmt ctx dot out, and I should be able to do something like hello world, and maybe get some output here. Remember, the output is coming through this std cout call. I'm passing in a transaction, but I'm expecting maybe to just see hello world when I run this. There it is. We are seeing hello world. So I think we can use the format2 function to start getting some data out of this format function. But let's make it relevant for our transaction type. So let's switch on the arg.type. And we're going to have two cases to look at. Withdrawal and case deposit. So let's format these output strings to be both as wide as withdrawal. So withdrawal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters wide. So let's do std format2. And again, the out iterator we're going to use is fmtctx.out. And let's do a format string that aligns to the left and is 10 characters wide. And we'll write the string deposit for deposit. And for withdrawal, we'll write withdrawal. Now for the transaction we created, it is a withdrawal. So if I'm lucky at this point, when I run this program, I should see withdrawal printed out on my screen. And there it is, a withdrawal. Now I would like to print a space after our first thing so that all our strings aren't running together. So we'll do a format2 to ctx out, and we'll just do a space. And next, why don't we print the date? And I believe if I go back to the format reference, there is format specs handling chronotypes already. So I should be able to just pass in that chronotype of the date if we're lucky. So let's try this out. Let's do std format2 fmtctx.out. Just do a replacement field and we will type arg.mdate. And since format can already handle date types, this should come out with October 7th when we print this. And there it is. Next, let's print out the comment. So we'll print a space. And then for our comment, I want to be careful here because somebody could in theory write a comment that's like 1,000,000 characters long if we let them. But I do not want to be printing that much data. I want to limit what my output looks like. Maybe do 60 characters. I'm going to create a string called str, set it equal to arg.comment. But if size of the string is too large, say greater than 60, what I'm going to do is I'm going to resize it to a string of 57 chars plus 3 dots at the end. So I'll do something like this: str equals std string str.begin str.begin plus 57 characters plus dot dot dot. Again, this is only if the comment string that somebody gives us is too long. And I don't need these brackets since I'm only doing one line after the if statement. But then I should be able to format this out. So std format to fmtctx dot out. That's hard to type. And we'll say that we want to print a left aligned string that's 60 characters wide and give it the value of str. And if we run this, we should see the comment show up. There it is. Now we can't really see it right now, but this comment should be about 60 cars. So the next thing we print out should be out here to the right somewhere. Which the next thing we're going to print out is the amount of the transaction. So I'm going to print a space. And then I think what I'm going to do is format out. And I want to print out a decimal number with 2 precision. And we'll put a $sign in front so it looks like dollars and cents. And the argument will be arg.m amount. Or actually, how wide do I want to make this? I'm going to do a width of 6. That way if we have a transaction maybe in the hundreds or thousands of dollars, it should still line up. So we're going to print that out as well. And there it is. So you have a bunch of blank space after groceries and a dollar amount. And actually, we're going to make that, instead of 6, let's add 2 more spaces. Let's make that 8 characters wide. And let's try it one more time to make sure it looks right. Okay, good. So let's make a second transaction with a big comment. Let's call it transaction 2. Let's make the comment very long. Let's say my son Venmo'd me $125.76 for the cash I gave him the other day to take his family to the local fair. That should be more than 60 chars, and so somewhere along this line this comment should get truncated and have ... And just to make the number line up, we'll do 125.76. And why don't we do a different day? Let's say November 11th, just to make sure that the dates and stuff are working out. And we'll say that's a deposit. Okay, so I think we changed quite a few things. That should look nice in our new system. And if we print this out, we'll print out transaction 2. Hopefully everything will be lined up and looking nicely. And that looks so good. We have deposit. Our dates are lined up. Here's our comment with the ... when it gets too large. There's the dollar amount lined up very nicely. I'm just loving this. I think this looks fantastic. Okay, so there you go. We created a custom formatter with a parse and a format function that we are using to very nicely line up values from a custom type that we created. I hope you found this video useful, and I'll see you next time. For bonus time, let's customize our parse function to add a little format spec so we can change the way the formatted output looks if we want to. Right now, our parse function does not look for any format specifiers. It simply returns an iterator to the end of the range. But according to this document, our parse function should look at the range from parse_ctx begin to parse_ctx end, parsing any format specs that it finds. So let's try that. Let's create an iterator called it and set it equal to the begin of the parse range. And let's say that if we're already at the end, that would mean there was no format specs provided. In that case, we'll just return that iterator, which is kind of what we've been doing this whole time. But now we want to think about what happens if somebody does provide a format spec to us. Let's use the letter N. I'm going to say N for name. So let's just come down here and pretend somebody gives us a format spec little n. And let's say that that means they want the months to be displayed as words rather than as numbers, because right now our year is being displayed as 2024 11/11. But maybe they want it to say November in words. So we'll use :n for name. What we can do is create ourselves a little Boolean member in our formatter. Say, we'll call it use month names. We'll set it to false by default, but when somebody passes in a format spec, we'll switch it to true. So let's say if the value of our iterator is equal to h, then we'll set use month names to true. And of course we'll increment the iterator. Now that's the only format spec I'm going to look for. But you'll notice that we do have to throw an error if the whole range is not parsed. In other words, if it is not equal to parse ctx end, or the unmatched character is not an empty bracket, we have to throw an error. And this isn't going to work if we don't add that line. So we're going to say if it does not equal parse ctx.end, and if it is not equal to the right curly brace, we need to throw an error here because somebody's given us a format spec we can't handle. So we're going to throw std format error, and we'll give a little message, say invalid format args for transaction. But if we successfully get past all of that, we can just return it and be done. So let's see what happens if we do that. Let's go to the part where we're printing out the date. Or actually, let's set a breakpoint at our first transaction and see what happens. And then we'll set a breakpoint at our second transaction and see what happens. Oh, it's yelling at me. What did I do wrong? No. For some reason I checked for h instead of n. I want to use little n. Use little n. See? If we give it a format spec, it doesn't expect, it was expecting h, and we gave it an n down there, it won't even compile. So this one should work. Okay, so let's step into the formatter here and watch what happens. So we're parsing. Right now it is pointing at the right curly brace, so there was no n found, but it is the right curly brace, so that's okay. So it's going to return that iterator. Now we're going into the format function, and if we hover over use month names, it's false. All right. So let's set a breakpoint at our next time through here and hit continue. Now we provided an n here, so let's step in. If it equals n, we're stepping into set use month names equals true. We've reached the end of our range, so we're going to return it. And now, as you can see, we hover over here and use month names is true. So what we can do is at the time when we're going to print out our date here, we can make a little if statement and say if use month names, std format to so in this case, I counted up the length of September is 9 variables, and that's the longest month name. Plus 4 for the year, plus 2 for the day, plus 2 dashes. That equals 17. So I'm going to do write a line, 17 characters, and then we'll do the format specs for chrono time. So if I come to std format and we look at the format spec for chrono time, okay, for the year we want %, capital Y, writes the year as a decimal number. And then we're going to have a dash. And since we're using month names, now we want to print out the name of the month. So for the name of the month, we want %, capital B. So we'll use percent capital B. And for the day, we're going to want percent %D. And we'll pass in arg.mdate. Then for an else statement, if we're not using month names, we're going to do what we had before, but I am going to stretch it out to write a line and be 17 characters wide. We'll do percent %y dash. Now I just want to do the month as a decimal number instead. Percent %m dash percent %d. Okay. So if we did this right, what we should see is for the first transaction, where we didn't pass in a format spec, it should be 2024-10-7, year, month, day. Whereas here, where we do supply a format spec, it should be 2024-the word November-11. So let's just run it and see what happens. And there we go. So they are right aligned. They're each 17 characters long, so they still line up even though one uses numbers for the month and one uses a day. So there you have it. We customized our parse function, and I think it's really cool. So I hope you enjoyed this bonus time, and have a great day.